AI, reinforcement learning. Hi, everybody. If you're looking to become a full-time data scientist and artificial intelligence (AI) expert from scratch, then you are at the right place. Today, we will acquire knowledge about reinforcement learning, which is also known as Q-learning. Before diving into details, let's get to know what reinforcement learning actually is. Reinforcement learning is an area of machine learning, and it is the training of machine learning models to make a sequence of decisions. It is about taking suitable action to maximize reward in a particular situation. It is employed by various software and machines to find the best possible behavior or path it should take in a specific situation. In reinforcement learning, the agent explores the environment by exploring it without any human intervention. It is the main learning algorithm that is used in artificial intelligence. Reinforcement learning differs from supervised learning in a way that in supervised learning the training data has the answer key with it, so the model is trained with the correct answer itself, whereas in reinforcement learning, there is no answer, but the reinforcement agent decides what to do to perform the given task. Deep learning consists of several layers of neural networks designed to perform more sophisticated tasks. The construction of deep learning models was inspired by the design of the human brain, but simplified. Deep learning models consist of a few neural network layers which are in principle responsible for gradually learning more abstract features about particular data. So, what's the significance of Q-learning in daily life? Let's talk about it. Some autonomous driving tasks, where reinforcement learning could be applied to include trajectory optimization, motion planning, dynamic paving, controller optimization, and scenario-based learning policies for highways. For example, parking can be achieved by learning automatic parking policies. Lane changing can be achieved using Q-learning, while overtaking can be implemented by learning an overtaking policy while avoiding collision and maintaining a steady speed thereafter. If we talk about industries, Q-learning has been widely used in automation industry. Oz Deep Racer is an autonomous racing car that has been designed to test out RL in a physical track. It uses cameras to visualize the runway and a reinforcement learning model to control the throttle and direction. Wave.ai has successfully applied reinforcement learning to training a car on how to drive in a day. They used a deep reinforcement learning algorithm to tackle the lane following task. Their network architecture was a deep network with 4 convolutional layers and 3 fully connected layers. In industry, reinforcement learning-based robots are used to perform various tasks. Apart from the fact that these robots are more efficient than human beings, they can also perform tasks that would be dangerous for people. A great example is the use of AI agents by DeepMind to cool Google data centers. This led to a 40% reduction in energy spending. The centers are now fully controlled with the AI system without the need for human intervention. So what are the challenges that are faced by reinforcement learning? Well, the main challenge in reinforcement learning lays in preparing the simulation environment, which is highly dependent on the task to be performed. When the model has to go superhuman in chess, Go or Atari games, preparing the simulation environment is relatively simple, but when it comes to building a model capable of driving an autonomous car, building a realistic simulator is crucial before letting the car ride on the street. Let's differentiate the two terms. Reinforcement learning works by interacting with the environment, while supervised learning works on the existing dataset. The reinforcement algorithm works like the human brain works when making some decisions, while supervised learning works as like a human learns things in the supervision of a guide. There is no labeled dataset present in reinforcement learning, while in supervised learning the labeled dataset is present. In reinforcement learning, no previous training is provided to the learning agent, while in supervised learning, training is provided to the algorithm so that it can predict the output. Reinforcement learning helps to take decisions sequentially, while in supervised learning, decisions are made when input is given. Talking about the significance of reinforcement learning, it is no doubt a cutting-edge technology that has the potential to transform our world. However, it need not be used in every case. Nevertheless, reinforcement learning seems to be the most likely way to make a machine creative, as seeking new and innovative ways to perform its tasks is. In fact, if you're interested in learning more about starting a machine learning and AI career, then be sure to check out our courses at the first link in the description. For further involvement, subscribe and turn on notifications so you don't miss more videos helping you to start your data science and AI career and more. Check out this playlist of our data science and machine learning lessons and see you in the next video. Take care.